Hey everybody, in this video we are going to work with radicals. We'll do some simplifying and then some operations with radicals. So this first radical we're going to simplify, the square root of 320. What I'm looking for is a square number that goes into 320. Like 4 is square because it's 2 squared. 9 is 3 squared. 16 is 4 squared. When I look at this number, I see 32 times 10. And if 32 goes in, then half of 32, 16 would go in, and 16 is a square number. So I could use 16. Double 32 is 64. Let's see if 64 goes into 320. 320 divided by 64. It does. 64 times 5. So we'll use that. We want the biggest square number we can find. So I'll change that 320 to 64 times 5. And then I'll just leave the variables just as they are. And since it's a square root, there's no number here for an index. That means the index is 2. So that's going to help us with these variables. The square root of 64 is 8. So I'm going to do the square root of 64. That's 8. And since the index is 2, I want to know how many groups of 2 can I take out of this 8. Right here, I can take 4 groups of 2 out of this. So x to the 8th, the square root is x to the 4th. And for y to the 12th, I can take 6 pairs out of this. I can take 6 groups of 2 out of 12, so y to the 6th power. And z to the 10th, I can take 5 groups of 2 out of 10, so that's z to the 5th. And I took the square root of 64, I did 4 groups and there's no leftovers. I did 6 groups, there's no leftovers. I did 5 groups here, there's no leftovers. The only leftover number is 5, so square root of 5, and that is my simplified number. Next, I'm going to do a cubed root. So I'm not looking for square numbers that go into 750, I'm looking for cube numbers. Like 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. 125 might work. Let's try that. 750 divided by 125 is 6. So the 750 I'm going to change to 125 times 6. Okay, now the cubed root of 125 is 5 because it's 5 cubed. So a 5 is going to come out. So I did the cubed root of 125, so I'm done with that. For x's, x to the 13th power, I'm looking for groups of 3 because the index is 3. 3 goes into 12 4 times, so I can take out 4 groups of 3. 3 goes into 4 1 whole time, so 1, y to the 1. And 3 goes into 22 7 whole times. 7 times 3 is 21. So that would be z to the 7th time. I can take 7 groups of 3 out of 22. But I've got some leftovers this time. So the cubed root of that 6 is left over. When I took 4 groups of 3 out of 13, I really only took out 12. So that leaves me with 1 left over. So x to the 1st power. When I took out 1 group of 3 out of this 4, that left me with 1 left over. And when I took out 7 groups of 3 out of this 22, 7 groups of 3 is 21. Out of 22 leaves me 1 left over. So there is my simplified form. Next, we are going to do some operations with radicals. I've got 3 different radicals here, none of which can be simplified. No square numbers go into 11 or 13, but I can combine the ones that are alike. So 3 times the square root of 11, and then 4 square root of 13 minus 8 square root of 13. 4 minus 8 is negative 4. Negative 4 times the square root of 13. Here I've got some to add, but I think I can simplify these. I believe 80 is divisible by 16. So 80 divided by 16 is 5. So I've got 5 times the square root of 5 times 16 plus 5 times the square root of 4 is a square number that goes into 12. 4 times 3 plus 5 times the square root of 125 is divisible by 25. 25 is a square number, and 25 times 5 is 125. The square root of 16 is 4, so I've already got a 5 out here, and now I'm taking the square root of 16, and that's 4. Here I've already got a 5 out here, and the square root of 4 is 2. And I've got a 5 out here, and the square root of 25 is 5. Now I can multiply. 5 times 4 is 20. 20 times the square root of 5 plus 10 times the square root of 3 plus 25 times the square root of 5. And I can combine some like terms. When I combine these, I get 45 times the square root of 5. And then this is left over plus 10 times the square root of 3. Next, I'm going to multiply with radicals. I can multiply the coefficients. Negative 3 times 4 is negative 12. 7 times 8 is 56. So I have to decide if any square numbers go into 56, and I think 4 does. 56 divided by 4 is 14. So that's negative 12 times the square root of 4 times 14. Do any square numbers go into 14? 2 and 7 go into 14. No square numbers. So I've got a negative 12 here, and the square root of 4 is 2. Then times the square root of 14, and negative 12 times 2 is negative 24. Times the square root of 14. Here I can distribute. Negative 7 times negative 2 is 14. Square root of 3 times the square root of 7 is the square root of 21. And then I have negative 7 times 1. So that's minus 7. And then square root of 3 times the square root of 3 is 3. So that's 14 times the square root of 21 minus 21. And these cannot be combined because they don't have the same radical. And no square numbers go into 21, so I can't simplify that any further. Next, we're going to do some more distributing. 3 times the square root of 6 times negative 4 times the square root of 6. That's negative 12. 3 times negative 4. And the square root of 6 times the square root of 6 is 6. Then, here I've got 3 times 5. That's 15. So plus 15 times the square root of 6. Here, negative 7 times negative 4 is positive 28 times the square root of 6. And negative 7 times 5 is negative 35. Negative 12 times 6, that's negative 72. I've got like terms here, 15 times the square root of 6 and 28 times the square root of 6. 15 plus 28 is 43 times the square root of 6. Then minus 35. And I've got some like terms here. Negative 72 minus 35, that's negative 107 plus 43 times the square root of 6. Here I can multiply the 3 and the 2, that's 6. And then when I multiply these variables, what I do is add the exponents. So that's times n, and then 3 halves plus 5 thirds. The common denominator would be 6. If I multiply the top and bottom here by 3, I get 9 sixths. And here by 2, and I get 10 sixths, which is a total of 19 sixths. So it's 6 times n to the 19 sixths power. Now this 19 sixths power is only attached to the n. I want to go one step further and make it 6 times a radical. And I've got that n inside the radical. The index here is this denominator. So the index is 6, and the power is 19. So that's 6 times the 6th root of n to the 19th power. And we're going to finish this video by converting between forms. This is in radical form. I want it in exponential form, so that would be x to the 8 over 5. The index is the denominator, 8 over 5 power. Now this could be in parentheses, this x. It doesn't have to be because it's the only thing attached to that power. In this case, if I mean for that 5 over 2 to be the power for the 5 and the x, we have to have these parentheses. If it's just one number or one variable, I do not need the parentheses. This one is going to be written in radical form. So 5x is both attached to the exponent. Up here, these weren't both attached, so only the n went under the radical. These parentheses say everything is attached to that power, so everything goes under the radical. The index is the denominator, it's 2. You never have to write an index of 2 because if it's blank here, it's understood to be 2. And then that is to the 5th power. I could put the 5th power right here. I could put parentheses around this and put it out here, or I could put parentheses around the 5x and put the 5th power here after those parentheses. I'm going to do this, parentheses with a 5th power. That's probably the clearest way I can write it.